Chapter 1.4 is going to be linear functions and their slopes. So let's start off with the slope of the line and the slope formula. So slope measures the steepness of a line, and the slope of linear functions, or the slope of a line, is always going to be constant. So that means that if you did the slope over different intervals of that line, it's always going to be exactly the same. So the slope formula here, the slope between 2 points x1 comma y1 and x2 comma y2 is going to be m equals y2 minus y1 divided by x2 minus x1. So it's the difference in the y coordinates divided by the difference in the x coordinates. So change in y divided by change in x. Or we can call it rise over run. So rise being the change in y, it's called rise because the y values are vertical, so it's rising. And change in x would be the run part. Run, change in x is horizontal, so run being a horizontal distance. So we can see, so I put a little note here where the x values cannot be equal, x2 cannot equal x1. So we'll see why that is on the next page. So we have a little graph here showing the slope of a line. So we have the slope between these 2 points, here and here. And it is the y distance divided by the x distance, measuring the steepness of the line. So let's do a couple examples here. So definitely memorize this formula. It's really, really important. So let's find the slope of the line passing through each pair of points. So we have the points -3, -1, and -2, comma 4. So before we find the slope, let's plot these points down. So -3, -1 is going to be here, -2, 4 is going to be up here. So we're trying to find the slope of the line that connects them. So we're trying to find the slope of that line that is connecting those 2 points. So let's do this slope formula here. So it's going to be m equals y2 minus y1 over x2 minus x1. So you can let either of the points be x1, y1, and the other one be x2, y2. So I'm just going to let this first one be x1, y1, and this second one be x2, y2, and then it's just plugging them in. So it's going to be y2 minus y1, so that's 4 minus -1. Obviously be careful with the positive and negative signs. And then x2 minus x1, -2 minus -3. 4 minus -1 is 4 plus 1, which is 5. -2 minus -3, -2 plus 3 is 1. So we get m equals 5 over 1, so m equals 5 for this one. Which makes sense because if we went over to the graph on the right, it's 5 units up and then 1 unit to the right. So that would be our slope for between those 2 points. So doing another one here, we have 1, 4 and 1, 0. So once again, let's plot these. So here's 1, 4, here's 1, 0. So we're looking for the slope of the line connecting them, which is a vertical line. So before we even calculate this, maybe try to think for a second what the slope is going to be. So let's plug these into the formula. So once again, I'm going to let that first coordinate 1, 4 be x1, y1. I'll let 1, 0 be x2, y2. So difference in the y coordinates, we have 0 minus 4 divided by difference in the x coordinates, 1 minus 1. This gives us -4 over 0. So -4 over 0, we cannot divide by 0. So this actually means, when this happens, when we get this actually means that the slope is undefined. So -4 over 0 is not the answer. We have to make sure that we're writing that the slope is undefined. Slope does not exist for a line connecting these 2 points. So vertical lines, if you have a vertical line, the slope of a vertical line is undefined. And let's see this next one. We have the points 2, 3 and -2, 3. So 2, 3 is going to be this point right here. And then -2, 3 is going to be right up here. So the line connecting them is going to be that horizontal line. So we're trying to find the slope of a horizontal line. So once again, try to think of what the slope would be before we even calculate it. in this case. So plugging in our values, change in y over change in x. I'm going to let the first ordered pair be x1, y1, second ordered pair be x2, y2. So y2 minus y1 is 3 minus 3 over x2 minus x1, that's negative 2 minus 2. That gives us 0 over negative 4. So 0 over negative 4, that's okay. We can have 0 in the numerator as long as it's not in the denominator. That gives us a slope of 0. So make sure you're simplifying this and write it as 0 and not 0 over negative 4. So horizontal lines have a slope of 0. So here are the four kind of main general possibilities for a line's slope. Either the slope can be positive, negative, 0, or undefined. If the slope is positive, that means the line rises from left to right, which means it is an increasing function. If the slope is negative, if we have a negative slope, that means it's falling from left to right, which means it is a decreasing function. And as we just saw in the previous ones, if the slope is 0, that means the line is horizontal. And if the slope is undefined, that means the line is vertical. Okay, so that brings us to the next thing, which is the point-slope form of the equation of a line. So we're going to have three main types of forms, three main types of equations or formulas for this section. We're going to have the slope formula, which we already did. Then we're going to have this point-slope form for the equation of a line. And then we'll have slope-intercept form for the equation of a line. Okay, so for the point-slope form here, what this comes from is it's based off of the slope formula. All of these formulas that we're doing are actually going to be the same formula. So this is just straight up based off of the slope formula. So what we're going to do is, starting with the slope formula, we're going to say that it has slope m, and it contains the points x1, y1 on the line. So instead of having an x2, y2 in the slope formula, we're going to replace x2, y2 with just x comma y. So x comma y is going to represent any point on the line, not some set point that we already have. So starting off with the slope formula, let's say we have m equals y2 minus y1 over x2 minus x1. So that's the slope formula. And we're going to let x2, y2 be x comma y. So all this means is that can represent any xy ordered pair. So instead of y2, we have y, so it's y minus y1 over x minus x1. So it doesn't look that much different right now. And all we have to do here is multiply both sides of the equation by that denominator, x minus x1. So this would be kind of like, if you want to think of it as cross-multiplying, we're multiplying x minus x1 on both sides. So when we do this, we end up getting m times x minus x1 equals y minus y1. Okay, so this is actually the point-slope form of the equation of a line. So it's just written in the other order, which is fine, but that's the order that we're going to be writing it in. It's y minus y1 equals m times x minus x1. So once again, it's just the slope formula rearranged, and you're probably thinking, well, why did we do that? It looks exactly the same, just rearranged. So we'll see why in these next examples for how we can, or when we're going to be using this. So for this example, let's write an equation in point-slope form for the line with slope 4 that passes through the point negative 1 comma 3. And then let's solve it for y afterwards. Okay, so we know that we are starting with this formula, y minus y1 equals m times x minus x1. So we know we're starting with this formula. Well, obviously we're starting with it because we just mentioned it a second ago. But the hint is that we're given a point on the line and we're given the slope. Hence the name point-slope form for the equation of a line. It tells you what you need for it. So we're given that the slope is 4 and the point, which is x1, y1, is negative 1 comma 3. So all we have to do is plug this in. Before I plug it in, let's just graph this and see what it's going to look like. So it's going to be negative 1 comma 3. So that's going to be a point right here. And then we have a slope of 4, so that means it's going to be 4 over 1. So it's actually going to end up looking like this, and we'll get into graphing these in a second. But you can see from the point that I plotted, the other point right here, and right here, you can see to get from one point to the other, I went up 4 and to the right 1, which was the slope of the line. Okay, so we're trying to come up with an equation for that line. So plugging in our values here, we're going to plug in x1, y1, and 4 into m. So it's going to be y minus 3, that was y1, equals m, which is 4, times x minus x1, which was negative 1. So as usual, be careful with the positive and negative signs. So simplifying this a little bit, it's going to be y minus 3 equals 4 times x plus 1. Instead of subtracting the negative, let's just add the positive. So this is the, right here is the point slope form. So that's point slope form, so that's kind of the first part of our answer here. There's the equation of the line. Now solving this for y. When we solve this for y, we have to do two things. We have to distribute the 4, so we get 4x plus 4, and then we have to add 3 on both sides. We have to isolate that y, so we have to add 3, the opposite operation of subtracting. So it's going to be y equals 4x, 4 plus 3, so plus 7. So that's something called something else. It's called the slope-intercept form. We'll mention that in a second. But there's our answer. We have our two forms of the equation of a line. So let's do one more here. So write an equation in point slope form for the line with slope -1 that passes through the point 5, -3. So once again, we know that we need to use the point slope form because we are given a point and we're given a slope. So the slope is -1, and x1, y1 is going to be 5, -3. So let's plot this out and just see what it's going to look like. So 5, -3 is going to be right here, and it has a slope of -1. So once again, we'll be graphing these more accurately in a second. So for now, just take my word for it. It's going to look something like that. So we're trying to come up with the equation of that line right there. So let's plug in these values. So it's going to be y minus y1. So that's y minus -3 equals -1 times x minus x1, which is 5. Clean this up a little bit. This is y plus 3 equals negative and then x minus 5. So you always want to kind of simplify it just a little bit when you're rewriting it in point slope form. So here's point slope form. And now solving this for y, we have to distribute the -1. So it's going to be -x plus 5 after we distribute that negative. And then we have to subtract the 3 on both sides. So subtracting the 3, we get y equals -x plus 2. Okay, so that is, we have the point slope form of the equation of the line, and then we also solved it for y, which is going to be called the slope-intercept form. Okay, so that actually brings us to the slope-intercept form. So here's our third main form for the equation of a line, or third main equation for this section. So once again, this also comes from the slope formula. So since a non-vertical linear equation is always going to have an a y-intercept, a non-vertical linear equation will always have a y-intercept, meaning it's just going to be passing through the y-axis. That means we know it's going to have some ordered pair, 0, b on the line. So if the x-coordinate is 0, that means it is a y-intercept, right? So we know it's going to have a y-intercept, so we know it's going to be 0, b on the line. So what we're going to do is we're going to start with the slope formula, and we're going to substitute 0, b into x1, y1, and then solve it for y. Once we do that, we're going to see that we get this equation of the line. So what I'm actually going to do, I just changed it in here. I'm going to start with the point slope form. I think it'll be a little bit easier. So starting with the point slope form, so y minus y1 equals m times x minus x1. So we know that this already comes, the point slope form comes from the slope formula. So since I'm using the point slope form here, it's just this, all of this comes from the slope formula. So what I'm going to do is I'm going to let x1, y1 be 0, comma b. So we're just saying that it's going to be some sort of, there's going to be some sort of y-intercept here. So it's going to be y minus b equals m times x minus 0, plugging in that point. And now we're going to solve it for y. So solving this for y, we get y equals, distributing the m, we don't have to write that 0, it's just m times x, and then we add the b to both sides, we end up getting mx plus b, which is our slope-intercept form for the equation of a line. So we can see why it's called slope-intercept form. B is the y-intercept, and the m is the slope. Okay, so functions in this form, which using function notation, f of x equals mx plus b, they are called linear functions, and the graph of every single linear equation or linear function is going to be a straight line, hence the name linear equation. And in order to graph a linear equation, we need at least two ordered pairs, because if we plot down 2 points, all we have to do is draw a straight line through it, and that's going to be our line. So before we get into graphing, let's just make sure we can identify the slope and y-intercept when it's in this form. So for the first one, we have f of x equals negative 2x plus 3. So this is in slope, and these are all in slope-intercept form. So our slope is going to be right here, and our y-intercept is right here. So our m is negative 2, and our b is 3. So a slope of negative 2 and a y-intercept of 3. Next one, we have g of x equals x. So this time we only have the variable, we don't have a constant at the end. So our m here is going to be what's multiplying on the x. Since there's nothing written there, we know it's going to be a 1, so the slope is a 1. Since there is no coefficient or no constant term written after that being added or subtracted, that means the y-intercept is going to be 0. Okay, and then the last one here, we have h of x is negative 7/9 x minus 5. So once again, we have the slope multiplying the x and the y-intercept afterwards. The slope is negative 7/9, and the y-intercept is going to be negative 5. So it's minus 5 at the end, so we know it's going to be negative 5. Okay, so now let's get into graphing linear functions that are in the slope-intercept form. So it's relatively easy. Like we mentioned, we only need 2 points to do this. So the first step is going to be, well, one, we have to identify the slope and the y-intercept. So the first step is going to be plot the y-intercept, which is 0, comma b. The second step is we're going to find a second point using the slope. So we're going to rewrite the slope as a fraction if it's not already written as a fraction, and then use the fact that it's the change in y over change in x. So we're going to start at the y-intercept and either go up and to the right or go down and to the right. Once we have that second point, we have to draw a straight line through it with arrows at the end, and then we're done. So I made a little note underneath here. If the slope is positive, go up and to the right. If it's negative, go down and to the right. You could switch it up a little bit and do it the complete opposite, and it would still work. I just think it's kind of nice to have it one set way that you're going to be doing this. So I'm going to be doing it this way each time. So let's do a bunch of examples here. So let's graph the linear function f of x equals negative 3/2 x plus 2. Okay, so we have to identify the slope and the y-intercept. So the slope is going to be negative 3 over 2, and the y-intercept b is going to be 2. So notice that like I was mentioning a second ago with this note, I always go up and to the right or down and to the right. What that means is if we have a negative, I always consider that negative to be in the numerator, which is why I wrote it in the numerator. So what that tells us then is that the negative 3 means we go down 3, and the positive 2 means we go to the right 2. Okay, so graphing this, starting with starting with the y-intercept. We have a y-intercept of 2, so we graph that. And then from that y-intercept, we're going to go down 3 and to the right 2 based on our slope. So down 3 to the right 2 is going to put us right here. And then we're going to connect these lines, or connect these points as a line. And we're going to get this, make sure arrows are on the end, and this is going to be our function f of x. So make sure, try to get in the habit of labeling. And since it's in function notation, we can just call it f of x. We don't have to write out the whole thing. Okay, so once again, we started at this point up here. We used the slope and we went down 3. And then we went to the right 2. Okay, so let's do a couple more examples here. For the next one, we have g of x is 3/5 x plus 1. So identifying the slope and the y-intercept. And we know these are linear functions because they have degree 1. It's a degree 1 polynomial, meaning the exponent on the variable is a 1. So our m here is going to be 3/5, and our b is going to be 1. Okay, so it's a positive slope, so this we know it's going to be an increasing function. Positive slope, increasing function. So first graphing or plotting the y-intercept of 1, so we plot that right here. And then using a slope of 3/5, we're going to start at that y-intercept. We're going to go up 3. So it's up 3 because it's positive 3. And then it's always going to be to the right if you do it the way that I was mentioning, to the right 5. So up 3 to the right 5, that's going to put us over, put us over here. Then connect those with a straight line. That'll give us this line right here, arrows on the end, label it, and that is our function g of x. And just to kind of make sure we did it right, we knew it was supposed to be an increasing function because the slope was positive, which means it's rising left to right, which we can tell that it definitely is. Okay, next one, graph the linear function negative x minus 2. So our slope, it's negative x, so our slope is negative 1. Our y-intercept is negative 2. So plotting down this negative 2 for our y-intercept, that's down here. When we go to our slope to try to figure out how to create another point here, this is not a fraction, this is an integer. We can write integers as fractions if we put them over 1, right? So negative 1 is the same as negative 1 over 1. So now this tells us to go down 1 because it's negative, and to the right 1. So from that point, we're going to go down 1 to the right 1. That's going to get us right here. And then we're going to connect them. And we're going to get this. So this is going to be our linear function, h of x. Okay, so hopefully that's relatively simple. You just need to find the y-intercept and then use the slope to give you another point here. So let's get into the equation of horizontal lines and then we'll do vertical lines afterwards. So we already said that if a line is horizontal, then it has a slope of 0. So that means if we had the equation y equals mx plus b, and so it's in slope-intercept form here, the slope is 0. So that means this m is 0. So that whole first term cancels off, and we're left with y equals b, where b is the y-intercept of the line. So equations of horizontal lines are going to be in the form y equals b, and these are called constant functions. So they're going to look like the horizontal line that's drawn there, where it's crossing through the y-axis at b, so they're pretty simple to graph. So let's just do one example here. So graph y equals 3. So y equals 3, so we go up to the y-intercept of 3, and we draw a horizontal line. So that is our graph, and we label it y equals 3. So pretty simple. So y is always going to equal 3 no matter what x equals. So y equals a number, it's a horizontal line. So for vertical lines next, if a line is vertical, we said that the slope is undefined. So what this ends up meaning is that the equation of a vertical line is going to be x equals a, where x is the x-intercept, where a is the x-intercept of the line. So if it's x equals a number, it's a vertical line at that x-intercept. So let's do this example. So graph x equals -2. So we go over to -2. It's x equals, we know it's a vertical line, so x equals -2 for the x-intercept, and then we draw a vertical line. And we get this, and we label it, so that would be our graph. So if it's x equals a number, it's a vertical line at the x-intercept. If it's y equals a number, then it is a horizontal line at that y-intercept. So these ones are technically not functions because they fail the vertical line test. Okay, so a few more pages here, just a couple other side notes and a couple other different forms and ways to do the graphing. So the next thing here is the general form of the equation of a line. So every line can be written in this general form. General form is when everything is set equal to 0. So we have ax plus by plus c equals 0. A, b, and c are numbers here, and x and y are obviously the variables. So if we're given a line in general form, and we're told to graph it, one way that we can always do this is by solving it for y and putting it in a slope-intercept form. So for example, let's graph this function by finding the slope in y-intercept. So 3x plus 2y minus 4 equals 0. So let's solve this for y. So solving this for y, we have to add 4 on both sides and subtract 3x. So we get 2y equals -3x plus 4. And then lastly, we have to divide everything by 2 to cancel off the 2 that's multiplying the y. So it's going to be y equals -3 over 2x plus 4 over 2, which is 2. So we just put this into slope-intercept form. So now we can tell that the slope is -3 over 2 and the y-intercept is 2. So when we're graphing this, we have a y-intercept of 2, slope of -3 over 2. So that means we go down 3 to the right 2. That puts us right here. And then we connect it with a straight line. So something like this. So that's going to be our line, and I'm just going to label it. When I'm labeling this, it's good to label it in the original form. So I'm just going to label it in general form. Okay, so if it's given to you in general form, just make sure that if you're trying to find the slope and the y-intercept, you have to solve it for y and put it in slope-intercept form first. Okay, and the last thing here, so let's say we're given a linear equation. It can be in any form. In this case, we have it in general form. But another way to solve these, or another way to graph these without using the slope and the y-intercept, is using the intercepts. So using the x-intercept and the y-intercept. So we can find the x-intercept by setting y equal to 0. We solve it for x. We find the y-intercept by setting x equal to 0 and solving for y. Once we find those 2 points, we plot them, draw a line through them, arrows on the ends, and we're done. So this way is obviously not too difficult because we're plugging in zeros, which usually is going to cancel things off, which is going to make it relatively simple. So let's do this example. Let's graph 4x minus 3y minus 6 equals 0 using the intercepts here. So we could 100% solve this for y and then use it, put it in slope-intercept form and do it just like we did it. But let's do it this way. So let's find the x-intercept first, which means y equals 0. So we're going to take this function, or this equation rather, and we're going to plug in a 0 into y. So it's going to be 4x minus 3 times 0 minus 6 equals 0. So that middle term cancels because it's 0. So 4x minus 6 equals 0. Now we have to solve this for x. We have to add 6 on both sides. We get 4x equals 6. Divide both sides by 4. We get x equals 6 over 4. And I'm just going to simplify this and get x equals 3 over 2. So as a coordinate, as an xy coordinate, this would be the coordinate 3/2, comma 0. Okay, and now next let's find the y-intercept. So that means x equals 0, so it's going to be 4x minus 3y minus 6 equals 0. So we're going to plug a 0 into x. So it's 4 times 0 minus 3y minus 6 equals 0. The first term cancels because it's 0. We get 3y minus 6 equals 0. We can add 6 to both sides and get negative 3y equals 6. And divide both sides by negative 3. When we divide by negative 3, 6 over negative 3 is negative 2. So we get y equals negative 2 as a coordinate. That's the coordinate 0, comma negative 2. So let's plot these 2 points here. So we have 0, negative 2, and 3/2, comma 0. 3/2 is going to be 1.5, so that's right here. And then we connect them. And this is our graph of this linear equation. Labeling it. Okay, so multiple ways to do these. One way, if it's not in slope-intercept form, you can put it in slope-intercept form by solving for y. You could use the x-intercept and the y-intercept by plugging in zeros. So it's a couple different ways to do it, and none of them are too bad yet. Okay, so that is it for this section.